Hi guys, Dr. Tim Kruse here. A little algebra, solving a linear system of equations by doing it a whole bunch of different ways. So I'm going to show you how to use all these methods: substitution, elimination, how to solve the system by graphing, and how to solve it by using a graphing calculator as well. So these are the two equations or systems that we're going to be dealing with: x plus y equals 3 and x minus y equals 7. I want to find out the x and y that works in both equations. I want to find that ordered pair that works in both equations. Same thing over here. I just added a system that was a little more difficult to solve algebraically. So 3x plus 2y equals 3 and 4x minus 3y equals 4. Again, I want to find the x, y coordinates that work in both of these equations. I'm going to start by doing the substitution method. I'm going to solve both of these systems. All right. I've got this one covered up. We'll get back to it in a second. I just didn't want to overwhelm you. So I'm going to solve this one first, going down the left side of the page, and then I'll solve this one going down the right side of the page. But the basic premise is to isolate y in either equation. That means get it alone. Isolate means get it alone. Or solve for y, like this over here where the y is alone. So we want to get the y alone in either equation. Doesn't matter, the first equation or the second equation, whichever looks easier to you. And then once we get y alone, then we take that expression over to the other equation and we replace y with our new expression. So we have the system here: x plus y equals 3 and x minus y equals 7. That's our system. I can pick either equation. I chose the one on bottom, so I chose x minus y equals 7. Now I'm going to do a little algebra to get that y alone. So I'm going to move the x over here. So minus x, you can write that in if you want to. My new equation looks like this. Let's see, next I want the y to be a positive y, because we don't care what negative y is. So I can multiply everybody by -1, or I can divide everybody by -1, or I can just reverse everybody's signs, however you like to do it. Ends up with an equation y equals -7 plus x. Now this is the preferred way of writing it. Put that positive x up front and the -7 in back. They both mean the same thing. They're both fine. It's just this is the preferred way of writing it because it looks more like y equals mx plus b. All right. Okay, now that we've got that, now that I've isolated y in one of the equations, I'm going to look at this equal sign and I'm going to say to myself, y can be replaced by x minus 7. And that's what I'm going to do. I'm going to replace y with x minus 7. And I'm going to do it in the other equation. So that x plus y equation, I'm going to take out the y and I'm going to replace it with x minus 7 like this. Always a good idea to use parentheses. Now we just clean it up. To get rid of the parentheses, we multiply by that imaginary positive 1 that's in front. So it's positive 1 times x is still positive x, and positive 1 times -7 is -7. So not much changed. It's just a good habit to, when you're doing substitution, it's a good habit to use parentheses, especially when there's a negative in front of the parentheses. We'll see that here in a minute. So add like terms, you got x plus x is 2x. Now let's plus 7 gives us 2x equals 10, and divide by 2, x equals 5. There's our x value. To get our y value, we just go back to either equation, go back up top to either equation, pick out whichever equation looks easier to you. I just grabbed the first equation, x plus y equals 3. Remember, equals means can be replaced by, so x can be replaced by 5. So here we go again. Take your x and replace it with 5. 5 plus y equals 3, minus 5, y must be -2. So our x is 5 and our y is -2. This is the xy ordered pair that works in both equations. And that's exactly how you check it. You take that 5, -2, and you put it in here and see if it works, see if it equals 3, and put it in here and see if it equals 7. If it works in both equations, you have the right ordered pair. All right, moving to the right side of the paper, solving that system that's just a little more difficult because it's got bigger coefficients in front of the x's and y's. Using substitution, I'm going to isolate y in either equation. Now I chose the top equation. Doesn't matter, either equation. I chose the top one, 3x plus 2y equals 3. Now I'm going to do some algebra and get that y alone. So minus 3x, you can write that in if you want. leaves us 2y equals 3 minus 3x. Now I've got to divide everybody by 2. I've got to make everybody half as big. So 2y divided by 2 is y. 3 divided by 2 is 3 over 2. You can use 1.5 if you like it better. Negative 3x divided by 2 is negative 3 over 2x, but you can use negative 1.5 if you like that better. That's fine. Here's the preferred way of writing it. Put the negative 3 halves x in front and the positive 3 halves in back. So it looks more like y equals mx plus b. All right, to finish the problem, I grab the other equation, the one that I didn't use, and I find the y, and I replace y with this expression here. So I'm going to take out the y, and I'm going to put this mess in its place, and it looks like this, 4x minus 3, there's the 3, and then open your parentheses and replace the y with this mess over here. Now we just got to do some algebra. 4x plus 9 over 2x minus 9 over 2 equals 4. Of course, you can use the decimals if you want. Here's a pro tip. If you're doing the fractions, if you're sticking with the fractions like I did, you can get rid of fractions if you just multiply everybody by whatever the denominator is. In this case, it's 2. So if I just make everybody 2 times bigger, if I make everybody twice as big, I'll have an equation that doesn't have any fractions in it. So I'm going to go times 2 times 2 times 2 times 2. I'm going to make everybody twice as big just because I don't like fractions. So 4x doubled is 8x. If I multiply this times 2, they cancel, leaving me 9x. Same thing here, minus 9. Double that, 8. Same equation, just twice as big. It just looks a little prettier, and I don't have to worry about fractions. Some people don't like fractions, myself included. So that's a little trick to get rid of your fractions. Add like terms, that's 17x. Plus 9 gives us this equation here. Divide by 17, x must be 1. Now, once you figure out what x is, go back up and grab either equation. I grabbed 3x plus 2y equals 3. Remember, it's going to work in both. So either one, whatever looks easier to you. And this says x can be replaced by 1. So replace that x with 1. 3 times 1 is 3. Let's minus 3 from both sides gives us a new equation of 2y equals 0. Divide by 2, y is the number 0. So here's my xy ordered pair that works in both of these equations. And that's how you check it. Put a 1 there and a 0 there, make sure it equals 3. Put a 1 there and a 0 there, and make sure it equals 4. If it works in both equations, you're sure that it's correct. Now let's do the same thing using what's called the elimination method. You see the word elimination there. We're going to eliminate something. We're going to make it go away. We're going to make it disappear. The easy way to do it is to match up opposites of x or y. It doesn't matter. Whatever's easier. So match up your x's and make sure one's positive and one's negative, or match up your y's and make sure one's positive and one's negative, because what happens then is you can eliminate them by adding these opposites. If I add opposites, I get 0. That's called elimination. So over here, this one is already set up nicely, this first system that we dealt with. Now my x's match, but they're not opposite signs. They're both positive. My y's match. See, it's 1y, and that's also 1y, so they match. And they're opposite signs. This guy is ready to go. I don't have to do anything. All right, all I have to do is just add them. So here's my system written without the brackets. When I add them, just add them vertically, up and down. X plus x is 2x. Y minus y is 0. I'm not going to write a 0 there. I'll just leave it blank. And 3 plus 7 is 10. So I have a new equation that doesn't have any y's. I eliminated the y's. 2x equals 10, divide by 2, x is 5. Go back up and grab either equation, the plus equation or the minus equation. I grabbed the minus equation, and I'm going to replace x with 5. So replace x with 5, figure out what y is. Minus 5, negative y is 2. Divide by negative 1, y is negative 2. All right. Let's do the same thing over here with this system. Now this one's a little harder. That's why I included it, because nothing matches. All right, that's 3x's, that's 4x's. They don't match. That's 2y's, and that's the 3y's. They don't match. They're opposites. That's good. I like that they're opposite signs, but their numbers don't match. So we got to do a little bit of math and kind of reconfigure these. So I'm looking at the y's, and I see that they're opposite signs, so I'm going to choose to eliminate the y's because half the work is done for me. The numbers need to match, and they need to be opposite signs. Well, I've got the opposite signs part, so let's just go with the y's. We just got to make these numbers match. Now, what I got to figure out is, what do these two numbers go into? 2 and 3, they go into a bunch of numbers. They go into 6 and 12 and 18 and a whole bunch of numbers. I'm just going to pick 6 because it's the lowest number. It sounds like less work. So I'm looking at 2 and 3, and I'm saying I could change both of those to 6. I could multiply this by 3. That'd make it 6. And I could make this 2 times bigger, and that would make it 6. So what I'm going to do is I'm going to make the top row 3 times bigger, and I'm going to make the bottom row 2 times bigger. And that's what my little 3 and 2 out here are standing for. I'm going to take the top equation, and I'm going to make it 3 times bigger. I'm going to take the bottom equation, and I'm going to make it 2 times bigger. So everybody times 3, everybody times 2. We still have the same system, it just looks bigger. All right, 3x tripled is 9x, 2y turns into 6y, 3 turns into 9. Everybody gets 3 times bigger. 4x doubles to 8, 3y doubles to 6, 4 doubles to 8. This is the same system, just with bigger numbers. Now notice my y's, they match. They're both 6y, and they're opposites. One's positive and one's negative. So that when I draw a line and add them, there's nothing there. I eliminated the y's. 17x equals 7, divide by 17, divide by 17, x is 1. Once you do that, just go up and grab either one of these equations and replace x with 1. Equals means can be replaced by. X can be replaced by 1. So replace your x by 1. 3 times 1 is 3. Let's minus 3 minus 3. 2y is 0. Divide by 2, divide by 2, y is 0. So 1, 0 is our ordered pair using elimination. All right, the graphing method is a good way to solve these as well. You just want to see where these two lines cross on a graph. Unfortunately, you got to draw a graph, and it's nice if you have some graph paper. So it's not always the favorite method. Oh, I was supposed to say graphing up there. Okay, pretend there's an H right there. I'll fix it later. Graping method? I don't know what that is, but it sounds horrible. All right, let's use the graphing method. Now, for the graphing method, we just have to isolate y in both equations. Now, there's no ifs, ands, or buts about that. It's got to be y equals. So we got to get y alone. And then we plot the graphs, and we see where they cross. So given this system here, I'm going to work on the first equation. I'm going to get the y alone. So I'm going to minus x, and I like to put the minus x right after the equal sign, and then my 3 is still positive. So I'm going to call this my first equation. Y1 is negative x plus 3. Same thing as this up here. I just reorganized it so that the y was alone. Now do the same thing to the second equation. All right, I'm going to minus x, so I have negative y equals negative x plus 7. And then I'm going to divide by negative 1 all the way through, which gives me this equation here, which I call y2, my second equation. All right, so I want to graph y1 and I want to graph y2. And let's just do it by hand here. All right, y1, if you look at the number out here on the end, this is why I wrote it this way, because the number on the end is where it crosses the y-axis. And the number in front of the x is your slope. That tells you what you're doing. After you find where you cross the y-axis, the slope gives you directions about where to go next. So the first equation crosses the y-axis at 3. So go 1, 2, 3 steps up. I'm talking about this point right here. Now from there, I have a negative 1 in front of the x. So I want you to think about that as a fraction, because I need 2 directions. I need to know if I'm going up and to the right or if I'm going down and to the right. Now this fraction here would be negative 1 over 1. So I'm going to go down 1 and over 1 from my y-intercept of 3. I'm going to go down 1 over 1. There's a dot. Down 1 over 1. There's a dot. Probably be easier if I use this end of the pen. Here's my y-intercept. Down 1 over 1. Down 1 over 1. Down 1 over 1. Down 1 over 1. And just continue until you kind of use up the whole graph. Now, if you want to find these dots on the other side of the y-axis, you just got to kind of throw your slope into reverse. Instead of going down 1, right 1, just throw it in reverse and go up 1, left 1, up 1, left 1, and everything lines up. All right, so that's y1. y2 says it crosses the y-axis at -7, and it has a positive 1 in front of the x, so that's 1 over 1. That's up 1 over 1 from -7. So 7 steps down, there's 5, 6, 7 steps down, up 1 over 1, up 1 over 1, and so on, and so on, and so on. And right there where they cross, that's the x and the y that works in both of your equations. So it's a nice visual, but it's only handy if you have graph paper and the numbers aren't too big, and it's nice if the numbers are all whole numbers and everything, so it graphs nicely. It gets a little messy when the numbers are fractions, and most of the time the numbers are fractions, so most of the time graphing is not the way you want to do this. But let me show you on this other system here. So on the other system, I'm going to work on this first equation. I'm going to get that y alone. Minus 3x looks like this. Divide by 2, divide by 2, divide by 2 looks like this. And you can use negative 1.5 and positive 1.5 if you like. Now, second equation, minus 4x gives me this equation. Now I'm going to divide everybody by -3. Don't forget the negative. Divide by -3 gives you y2. Divide by -3 turns it into a positive fraction. Negative divided by negative is a positive 4 over 3. And divide by -3 makes it a negative fraction, because positive 4 divided by -3 is a negative fraction. Now this one we have to use the fraction, because 4 divided by 3, that's 1.333333 repeating forever. All right, we don't want to round it because it'll mess up our graph. So if it's a nice decimal like 3 over 2, which is exactly 1.5, go ahead and use the decimal. But if it's not a nice decimal like 1.33333 repeating forever, don't use that decimal. Just go back and use the fraction. Here's my first equation. Here's my second equation. My first line, my second line. The first line crosses at, let's go ahead and call that 1.5. All right, it's going to cross at 1.5 steps up. So 1.5 steps up right there. And from there, it's going to go 3 steps down, negative means down, 3 steps down over 2. So from here, now it's kind of hard, see, when it's fractions, I got to go 3 whole steps down. So the size of a step is the size of a square. So I'm going to go 1 whole step down, 2 steps down, and 3 steps down. Notice I'm still kind of halfway. And then I want to go 2 steps over. So I'm halfway, 2 steps over right there. And I can do it again. I can go 1 whole step down, 2 whole steps down, 3 whole steps down, and 2 steps over. Puts me right there. And we draw our line. And of course you can reverse it and go 3 up and 2 left if you want to find that dot right over there. Second equation says it crosses the y-axis. See, this is where it gets tricky when it's not, nice whole numbers like this that are easy to graph. It crosses about, that's 1 1/3, crosses about 1 1/3 steps down. So if I go 1 whole step down, and I have to kind of guess where 1/3 of a step is. So I want to go 1 1/3 of a step down. Now to find the next point, I go 4 steps up and 3 steps over. Now look where you're at here. All right, I'm just under this blue line. So I'm going to go 1 step, 2 steps, 3 steps, 4 steps up. I'm still kind of under the blue line. And 1, 2, 3 steps over. And if you graph that very, 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 very carefully, you'll see that they cross right here at 1 step to the right and 0 up and down. 1, 0 would be the solution to that one. A little harder to graph, a little harder to do the algebra. Graphing is not the favorite method of solving linear systems. Substitution and elimination are better methods, quicker methods, because sometimes you wind up with a graph like this. It's super hard to graph. All right, and I want to show you how to do the same thing on the graphing calculator. If you have a graphing calculator available, it's a nice, easy way to solve these systems. So same system. If you're going to put it in the graphing calculator, you have to make it say y equals, because that's what we got here in our y equals button right there. So I need it to say y equals this and y equals that. And I'm going to put those into y1 and y2, my first 2 equations. Once I get them in there, I'm going to use the appropriate zoom, and I'm going to calculate what's called the intersection. And they will tell us where those 2 lines cross. So let's go ahead and put these in. Y equals negative. Here's your X button right here. X plus 3. And then let's go down to X minus 7. So X minus 7. All right, now I said use an appropriate zoom. It's just, whatever works. You can start with zoom standard. Zoom standard is a 10 by 10 graph. So it goes 10 right, 10 left, 10 up, 10 down. And sometimes you get lucky. So if you hit zoom standard and enter, you might get lucky. And in this case, we did. All right, you see that Y1 was the downhill line, and we knew that was going to go downhill because it's a negative slope. So Y1 was the first line to show up going downhill. Y2 was the second line to show up, and it has a positive slope, so it was going uphill. All right, they cross right there where the two lines cross, and to find that, we're going to use calculate. It's the second function of the trace button. It says, what do you want to calculate? Go down to number 5, choose intersection. And now they ask you a bunch of questions. They're asking, are you on the first curve? I'm just going to move around so you can see the dot there. Sometimes you can put 3 or 4 or 5 curves on the same screen, so they're just kind of verifying that they're on the right curve. And I'm going to go ahead and say, yes, you're on the first curve. They call everything a curve, even if it's a line. Now it bounced me down here to this line here, and it says, hey, is this where you want to be? Are you on the second curve? And I'm going to say, yeah, sure I am. If there's only 2 lines on there, you really don't have to think about it. And then they always ask you if you want to guess. No, we never want to guess. Just hit enter again. And there's your solution. 5, negative 2 is where the 2 lines cross. Let me do it for this one right here. Same thing. Let's go back to y equals. I'll go ahead and put it over here. All right, y equals, we want... Well, let's clear that first. Here's your clear button. Oh, that light is not good. Y equals negative 3 over 2x. Now I'm going to show you how to put it in with the 84. If you'll hit alpha F1, it'll bring up a nice fraction thing. If you guys didn't know that already, it's really handy. Choose the first option there, and I can put in my fraction negative 3 over 2. So negative 3 over 2. Now you want to get out of that fraction. Don't be down there with the 2 and put an x down there. Get outside the fraction and put your x. And then plus 3 over 2. Or you can use 1.5. It's just fine. On the second equation, let's clear that. I'm going to show you how to put it in if you're like an 83. You guys on the 83s, you don't have this fancy fraction button. So on the 83s, you got to enclose the 4 divided by 3 in parentheses like that. That's 4/3 if you're using an 83. And then my x, and then minus 4/3. Whoops, I forgot. Parentheses. And let me just double check. That looks about right. Let me just make sure I got it in there right. So 4/3 x minus 4/3. All right, let's zoom. And I'm just going to go ahead and see if I get lucky with zoom standard, a 10 by 10 graph. Hit enter. There's the downhill line, and there's the uphill line. So the first line that showed up was going downhill because my slope was negative. Second line that showed up was going uphill because my slope was positive. Where do they cross? Let's go to calculate. Second, calculate where they intersect. Whoops. Or you can just hit number 5 if you want to. And I'm just going to go real quick. There's only 2 lines on the graph, so I'm just going to hit enter, enter, enter without even thinking. And the intersection is 1, 0. All right, guys, the last thing we're going to do is I got a couple of word problems that you're welcome to try if you want to. This is kind of practice for you. But it's just going one step further, and they're making you write the equation. So, for example, here's a money problem. And they say they have a bag and it has 37 coins in it. Some of them are dimes and some of them are quarters. All right. I'm going to use D for the number of dimes and Q for the number of quarters. So I know there's 37 coins in there. I just don't know how many dimes and how many quarters. So equation number 1 is usually your first sentence there. And it says the number of dimes plus the number of quarters adds up to 37 coins total. Now, the second equation, or the second line in your word problem is usually, well, how much money do you have in the bag? They told you how many coins you have. a certain number of dimes and a certain number of quarters added together means I have 37 coins in my pocket. The second line usually tells you how much money that is. So it says the total amount of money in the bag is $5.05. So that's equation number 2. So usually the first line is equation 1, second line is equation 2. Equation 2 says, okay, let's say I had 1 dime in there. That'd be 10 cents, right? 10 cents for each dime. If I had 2 dimes, it'd be 20 cents. And if I had 3 dimes, it'd be 30 cents. It's 10 cents for every dime that I have. So whatever the number of dimes I have right here is, I'm going to multiply it times 10 cents to find out how much money my dimes are worth. And then same thing on the quarters. It's 25 cents for every quarter that's in my pocket. If I have 1 quarter, it'll be 1 times 25. If I have 2 quarters, it'll be 2 times 25 for 50 cents. And if I have 3 quarters, it'd be 75 cents, 3 times 25. So every quarter that I have is 25 cents. Now, how do I turn that into an equation? I just say, okay, however many quarters I have, D stands for the number of quarters in my pocket. However many quarters I have, I'm going to multiply that times 10 cents. Now, since we're speaking money, we have to write 0.10. It's 10 1/100ths of a dollar. It's 10 pennies. It's 10 cents. And then however many quarters I have in my pocket, this is the number of quarters. For every quarter you have in your pocket, you're going to multiply it times 25 cents. So 10 cents for every dime plus 25 cents for every quarter needs to add up to $5.05. That's my second equation. All right. Now from there, you can solve it any way you want to. All right. Our system right now looks like D plus Q equals 37 and 0.10D plus 0.25Q equals 5.05. Or if you want to use X's and Y's, which you might need to, if you're going to put it in a graphing calculator, you want to use Y. So it's the same letters, just make D change to X, and everywhere you have a Q, make that a Y. And the system looks very similar. And then solve it any way you want. Substitution, elimination, graphing calculator, graphing the hard way, whatever you like the best. So right here, I would pause the video, try and work this out, see how you do, and I'll show you the answer here in a minute. Okay, so let me just go over the solutions real fast because we've already talked about all this. I took the first equation and solved it for Q. This is using substitution. I can get the D alone or the Q alone. It doesn't matter. I chose Q. So Q can be replaced by negative D plus 37. So in my other equation, in the second equation, I'm going to take the Q out and I'm going to replace it with negative D plus 37 like this in parentheses. Now this turns into a little bit of math, a little bit of algebra. You have to multiply everybody in the parentheses times 0.25. And it looks like this. 0.25 times negative D, positive times negative is negative 0.25D, and 0.25 times 37 is 925. Add your like terms, in this case subtract, and you get negative 0.15D. Add 0.15D to, whoops, sorry, did that wrong. I want the D to stay there. I want a minus 925 from both sides. So minus 925 minus 925 gives us this equation. And then the last thing you always do is divide whatever this number is, divide it away from the D. So divide by negative 0.15, divide by negative 0.15. The number of dimes you have is 28. To find the number of quarters, oh, well, heck, you could use this equation and change D to 28. You could use this equation and change D to 28. You can use this equation and change D to 28. Whatever you think is easier. This equation is probably the easiest, but I think I chose the first one. Yes, I did. That's okay. It's still pretty easy. Change D to 28. D can be replaced by 28. So replace D with 28. Minus 28 minus 28, Q is 9. So you have 28 dimes and 9 quarters. And you want to take that back up and plug it back into both your equations and make sure it works. Over here on the right, did the same thing with elimination. All right, now this one's a little harder. My D's don't match, and they're not opposite signs. My Q's don't match, and they're not opposite signs, so I'm not getting much help here. I chose to eliminate D's. It doesn't matter. Eliminate the Q's or eliminate the D's. It's your choice. I chose D, and I'm looking at them and I'm going, well, that's 10 cents. If I made it 10 times bigger, that would be 1. That'd be $1. If I had 10 dimes, that would be $1. Now look up here. I already have 1. To change this to 1, I have to make it 10 times bigger. And not only that, I want it to be negative as well because I want them to be opposites. I want them to match and I want them to be opposites. So it's kind of tough. This is a 1. This is smaller than 1. To make it a 1, I need to make it 10 times bigger. Now, not to confuse you, but I could have done it over here too. This is a 1. This is smaller than 1. To make that a 1, I got to make that 4 times bigger. So it's your choice. But I chose to change the dimes. All right, 1 just means I'm multiplying everybody by 1. It just means I'm not going to change the first equation. So 1 times everybody gives me the same equation. Now, negative 10 times everybody, negative 10 times 10 cents is 1, negative 1. Negative 10 times positive 0.25 is negative 2.5. And negative 10 times 5.05 is negative 50/50. So there's a little bit of algebra, a little bit of multiplying, but that makes my d's match and they're opposites, so they go away and turn into 0. And the rest of the equations like this. Divide by negative 1.5 on both sides. You got 9/4. Grab either equation, whichever one you like. All right, I chose d plus q equals 37. Q can be replaced by 9, so I replaced q with 9. Minus 9, d is 28. And then finally, graphing. To use the graphing calculator, or I mean, you can graph it on graph paper if you want to, but I wouldn't advise it. All you got to do is just isolate the y. So I changed my, let me look at my system here. I changed my d's to x's, and I changed my q's to y's. All right, and then I grabbed the first equation, minus x, and I got y alone. That'll be my first equation. I grab my second equation. Now this one, here's a little algebra tip, a little pro tip. If you want to get rid of decimals, just multiply by 10 or 100 or 1,000 or whatever it takes to turn those into whole numbers. So since I got 2 decimal places here, I need to multiply everybody by 100 to get rid of the decimals. I just like doing that because I don't like messing with decimals. So you don't have to. You can work with this equation right here. But it's kind of nicer looking if you just make everybody 100 times bigger. So multiply times 100 gives me 10, times 100 gives me 25, times 100 gives me 505. And then it makes the algebra look a lot nicer too, a lot less scary. Minus 10x both sides, divide everybody by 25 gives you your second equation. Plot them on a graph, see where they cross, and you're at 28,9. Okay, and the last problem, just for extra practice for you if you like, is a shopping problem. All right, maybe you're going to Lowe's and they got, crocus and daffodil bulbs on sale. So maybe you have room for 40 bulbs. And some of them will be crocus. I'll use C for crocus bulbs, and some are daffodil. So C will stand for the number of crocus bulbs that I buy from Lowe's, and D will stand for the number of daffodil bulbs that I buy from Lowe's. So the number of crocus bulbs plus the number of daffodil bulbs has to equal 40, because that's all I got room for is 40 bulbs. That's our first equation. Now, second equation, remember it's usually money. How much does this cost? So crocus bulbs cost a quarter, 25 cents each, and daffodil bulbs cost 65 cents each. And you only got $14.80 to spend. So you're trying to find a mix of crocus and daffodils to get with $14.80, and you want to make sure it doesn't go over 40 bulbs. So equation number 2 looks like this: 25 cents for each crocus plus 65 cents for each daffodil. So it's the number of crocus bulbs that you're going to buy times 25 cents, like this, and then the number of daffodil bulbs that you're going to buy times 65 cents for each of those. And you can't go over $14.80. All right, or you can make it 100 times bigger, and it looks like this, which is a little friendlier. Either one's fine. These are the same equation. This equation and this equation, same equation. This one has decimals. This one's bigger and has whole numbers. I always prefer to, mess with the equations with whole numbers. It's less confusing, but you can do what you want. All right, so our system looks like this if you're using C's and D's. I'd go ahead and leave it C and D if you're using substitution or elimination. If you're grabbing your graphing calculator, I would change them to X's and Y's, and then you'd get your Y's alone and use your graphing calculator. All right, so let's run through this. Hopefully you paused the video and tried it on your own, but whatever, your choice, it's America. Substitution, you take either equation and get one of the variables alone. It's really your choice. I chose to get C alone this time. So minus D says C can be replaced by negative D plus 40. In my other equation, I replace C with this mess right here. So it looks like this. 25 times C is 25 times, and we replaced C with this stuff in parentheses. The rest of it stays the same. And now we just do some algebra. Negative D times 25, negative 25D. 25 times 40 is 1,000. Add like terms, that's 40D. Let's minus 1,000 gives us this equation. Let's divide by 40, divide by 40. D, or the number of daffodil bulbs, must be 12. To find C, just go grab either one of your beginning equations, whichever looks easier. I grabbed this one. I'm going to replace D with 12. Replace D with 12. Minus 12 gives us C is 28. So 28 crocus bulbs and 12 daffodil bulbs. And make sure you plug those into, both of your equations. So plug them in here, make sure it equals 40, and plug it in here and make sure it equals 1480. Elimination, I don't see anything matching, and I don't see opposite signs, so we got some work to do. You can make the D's match, or you can make the C's match. It's totally up to you. I chose C. I notice this is 1, this is 25, so the 1 needs to be 25 times bigger, and it also needs to be opposite. This one's positive, so this one needs to be negative. So I'm going to multiply that 1 by negative 25, which means I need to make the whole equation that much bigger. So everybody gets 25 times bigger, specifically negative 25 times bigger. All right, so negative 25 times everybody gives you this equation here. And then when I multiply by 1, I'm just saying, well, 1 times everybody, that's the same thing. It just means I'm not going to mess with this equation. So same equation. This eliminates the C. They turn into 0. And I'm left with this equation here. Divide by 40, divide by 40. There's your D equals 12. Grab either one of the original equations and replace D with 12. I chose this one up here. Replace D with 12. Minus 12, C equals 28. All right, and then finally graphing, I switched to x's and y's. So I grabbed the first equation and I minus x to get this equation here. Second equation's a little more work. Let's minus 25x to get this. Let's divide by 65 all the way through. All right, now dividing by 65, you can leave it negative 25 over 65 if you want to, but it's good grammar in math to reduce every time, and your calculator will reduce your fractions for you. And then this one here, divide by 65, so you can write it as 1480 over 65 if you want, but it's better grammar to reduce. So tell your calculator to reduce that fraction. And we had to use fractions on this one because the decimal's horrible. All right, the decimal goes on and on and on and on, so we're not going to use the messy decimal. We're going to leave it as a fraction and leave it exact. We don't want to round anything. Put y1 and y2 into your calculator, calculate that intersection, and you wind up at the same place. All right, guys, that's it.